I'm Alex. This is Code Along with Alex, and today we're going to configure minimum and maximum memory constraints for a namespace. So let's dive right in. So this is going to set the minimum and maximum values for memory constraints on containers running in our namespace. And so we're going to specify these values using a limit range object. And if a pod does not meet the constraints imposed by the limit range, it cannot be created in the namespace. Sounds good. Today we're using the Killer Coda Kubernetes Playground. It's pretty awesome. It's free to use. I definitely recommend it. Let's get going. So to start, we'll create a namespace. We'll use kubectl, create namespace, constraints, mem, example. Okay, cool. Now let's create a YAML file where we're going to declare the configuration for our limit range object. And thus our pod. Okay, so we'll touch memory constraints that YAML. And let's open that file, nano. Start out by declaring an API version field, the value of v1, kind field, the value of limit range, metadata field, which will have some nested fields, or just one, the name field, and we're going to set that to mem min max demo CTR, or actually not CTR, LR, limit range. And we'll specify a spec field, which will have some nested info. Just start limits, a max, memory, which we'll set to 1 gigabyte. Then we'll take a min memory, which we'll set to 500 megabytes. And then finally, a type field, which we'll set to container. And now we should be good to go. Indentation looks fine, I believe. And kubectl will let us know if anything is not fine. Okay, cool. We saved it. Now let's apply the YAML and create our limit range. Kubectl apply -f, and then memory constraints.yaml, and then specify the namespace, which I already forgot the name of. It is, I hate when that happens. There it is. Constraints mem example. We should now have a limit range created, and we do. Now let's view some details about this limit range. Again with kubectl, get limit range mem min max demo lr, and then specify the namespace equals constraints. I spelled that right. It's weird sometimes when there's a line break. Example. You can see not too much information because I forgot to specify output is YAML. There we go. So if we look, we can see the limits that we specified, where the max memory is 1 gigabyte and the min memory is 500. Very nice. And so even though we didn't specify default values in the configuration file, they were created automatically. So whenever we define a pod within the constraints mem example namespace, Kubernetes will perform these steps. If any container in that pod does not specify its own memory request and limit, the control plane assigns the default memory request and limit to that container. Okay, Kubernetes will then verify that every container in that pod requests at least 500 megabytes of memory. And finally, it'll verify that every container in that pod requests no more than 1024 megabytes or 1 gigabyte of memory. Okay, so next, let's declare a manifest for a pod that has one container, and within the pod spec, the sole container specifies a memory request of 600 megabytes and a memory limit of 800 megabytes. These satisfy the minimum and maximum memory constraints imposed by the limit range. Let me create a new YAML file called memory constraints pod.yaml, and then let's open that with nano. Let's start by declaring an API version field, a kind field, which is such a pod, metadata with just a single nested field called name, and we'll set that to constraints mem demo. Then a spec field with a bunch of nested goodness, containers, start the name, which we'll set to constraints mem demo ctr. Next, we'll specify the image, and today we'll use our friend Nginx. Next, declare a resources subfield, which is itself comprised of subfields, limits, so much spacing, memory, 800 megabytes, and then requests, memory, 600 megabytes. Awesome. This looks good. Just double checking it one last time. All right. Save that. And now let's create the pod with kubectl. So kubectl apply -f memory constraints pod.yaml namespace equals the constraints mem demo, right? Let me double check. Constraints mem example. I think that looks good. Yeah, let's do it. And our pod was created. Awesome. Now let's verify that our pod is running and the container is healthy. Do that again with kubectl, get pod, constraints, spelling, mem demo. And then the namespace equals constraints mem example. And you can see it's running and it's about 30 seconds old. And like last time, I forgot to pass output into YAML. And we get more info this time. And so if we navigate to the resources limits subfield towards the top, somewhere, there it is. We'll notice that it obeyed or it satisfied or the parameters that we declared in our configuration YAML. Nice. All right, let's delete this pod and move on with another example. So kubectl delete pod constraints mem demo namespace equals constraints mem example, and the pod is gone. Okay, let's attempt to create a pod that exceeds the maximum memory constraint of the namespace. So we'll declare the manifest for this pod, some more YAML, and then try to create it. So let me create a file called memory constraints pod2.yaml. And let's open that with Nano. Okay, start by declaring the API version, kind, it's a pod, meta, data, name, constraints, mem demo2, spec, containers, name, constraints, mem demo2 container, image, which is Nginx, and resources, which will have some nested information, namely limits, memory, which will try to set to 1.5 gigabytes, which exceeds the max that we declared for the namespace, and then requests. Which will set to 800 megabytes. Does that look good in terms of indentation? Yes, it does. Save it. Let's try to apply that. kubectl apply -f memory. Oops. Constraints. pod2.yaml namespace equals. I already forgot the man. Goldfish memory. Constraints mem example. Ooh. And you can see the output shows that the pod does not get created because it defines a container that requests more memory than is allowed. No bueno. Okay. Now let's try to create a pod that does not meet the minimum memory request. So let's create another YAML file called memory constraints pod3.yaml. And then let's open it with Nano. So the API version v1, kind to pod, metadata to have a single nested subfield called name. And we'll set this to follow our naming convention today, incrementing by 1. Next, let's do a spec field, which itself has some nested fields. Start off with containers. We'll specify the name to be constraints mem demo 3 container, which also follows our naming conventions for today. We'll use Nginx again for the image. And we'll specify resource limits and requests memory nested fields. So resources limits ooh, the more you know. Should have tabbed the whole time. At least I learned. Okay, it's not perfect. That's probably why I just spaced. Okay, and then tab it. Well, that's nice. At least you have that. That does save some aggressive spacebar smashing. Okay. I need to see if there's like a macro or like a shortcut where I can maybe assign like Control Shift and then X or N, where N is the number of copies, or Control Space N, where N is the number of copies of the space, and I set that as like a macro key on my keyboard. That could be nice, actually. I might investigate how to do that. That would be a fun little project. Okay, save this. Let's attempt to create this pod. And you can see that the minimum was 100 megabytes, which is far below our minimum namespace default of 500. Let's try to create this. kubectl apply -f memory constraints pod 3 namespace equals constraints mem example. I remembered. Okay. Oh, and there's a typo in the YAML. Let's try to fix that. I think this happened recently when I forgot to put a space between a colon, but I don't see that now, so I'm guessing that there's just an issue with indentation. But let's double check. Okay. That looks fine. Okay. That looks chill. Okay. Maybe it doesn't like the tab. I would be so annoyed if it doesn't like that. I would not be surprised if it's that, to be honest. Yeah. Okay. Let's try it again. Yeah, don't do tabs with Nano. It'll get your kubectl YAML all busted. Okay. And you can see that our configuration or our manifest was not chill because our minimum memory was below the default for this namespace. Okay, what happens when you specify no memory, or you do not specify any memory request or limit when you try to create a pod? So let's see what happens when we do that. We'll create a file called memory constraints pod4.yaml, and let's open that with Nano. And this one will be short. API version v1. Avoid the tabbing so you don't get errors. Okay, metadata name. We'll increment our default name by 1. Spec containers name constraints mem demo for CTR. And image is nginx. And that's it. Okay. Now let's try to create that pod. All right. kubectl apply -f memory constraints pod 4 YAML namespace equals constraints mem example. Okay, the pod's created. Now let's view info about the pod. kubectl get pod constraints mem demo for. So I mean, it's a good sign it didn't just fail like the last two. So constraints mem example namespace, and we want the output to be YAML. And I spelled something wrong, which is fine. Constraint. There we go. And let's navigate to the resources subsection towards the top. And you can see the cluster applied a default memory request and limit from the limit range. So chill. Okay. So this means that the definition of that pod will show those values. So let's check that info. kubectl describe pod constraints mem demo for namespace equals constraints mem example, and then output equals YAML. And I spelled something wrong. I guess, does this not have an output? Oh yeah, it doesn't. Okay. Okay. What are we seeing here? So it's kind of like giving us information. Okay, yeah, the limit 1 gigabyte, that matches. It's still running. Okay, cool. Nginx. Awesome. So let's delete our pod. We don't need it anymore. kubectl delete pod constraints mem demo for, and then specify the namespace equals constraints mem example. And it's gone. So the maximum and minimum memory constraints imposed on a namespace by a limit range are enforced only when a pod is created or updated. If you change the limit range, it does not affect pods that were created previously. Good to know. And then as a cluster administrator, you might want to impose restrictions on the amount of memory that pods can use. For example, each node in a cluster has 2 gigabytes of memory. You do not want to accept any pods that request more than 2 gigabytes of memory, because no node in the cluster can support the request. Okay. Or a cluster is shared by your production and development departments. You want to allow production workloads to consume up to 8 gigabytes of memory, but you want development workloads to be limited to 512 megabytes. You create separate namespaces for production and development, and you apply memory constraints to each namespace. Okay, that makes a lot of sense too. Interesting. That would be a fun kind of tutorial project to do. Check back. All right, so let's clean up and delete our namespace because we won't need it anymore. kubectl delete namespace constraints mem example. That was our whirlwind tour of configuring minimum and maximum memory constraints for a namespace in Kubernetes. I will link the documentation in the video description, as well as the Killer Coda Kubernetes playground that I used today. Thanks for hanging out with me. I had a lot of fun. Hope you did too. I'm Alex. This is Code Along with Alex, and I hope to see you next time. Bye.